Now next topic is prime ideal and maximal ideal. So firstly we will see the definition of prime ideals. Let R be a ring a proper ideal P is a prime ideal in R if whenever AB belongs to P implies either A belongs to P or B belongs to P. So R is a ring. A proper ideal P is called a prime ideal in ring R if whenever AB belongs to P, either A belongs to P or B belongs to P. Now some examples. First, NZ is a prime ideal in Z if and only if N is prime. एक सेकेंड रुकना. So here our ring is set of integers. If I take ideal as 2z. Now what does definition say? That AB belongs to 2z implies either A belongs to 2z or B belongs to 2z. This means that 2z is a prime ideal of z. Now if I take, say, ring is set of integers only. Now if I take ideal as 4z, now if I pick any element from this ideal, 4 is equals to 2 into 2. This can be written as 2 into 2. This belongs to P and P is my 4z. But you can clearly see that neither 2 belongs to 4z nor 2 belongs to 4z, because our definition says that if P is a prime ideal, then AB belongs to P implies either A belongs to P or P belongs to P. We can clearly see that 2 does not belongs to this 4z. So 4z is not a prime ideal of z. So if nz wants to be a prime ideal, then n has to be prime. If it is not prime, then it cannot be a prime ideal. Second example. In Zx, generator X is a prime ideal in Zx. Third example, let P be a prime, then generator x comma 2 is a prime ideal in ZX. Fourth, singleton 0 is a prime ideal in R if and only if R is an integral domain. This means that our prime ideal is singleton 0. This is a proper subset of this ring RZ. Now if A into B belongs to P and P is singleton 0, this means that AB is equals to 0, and we know that Z is an integral domain, so it does not have 0 divisors. This implies that either A is 0 or B is 0. Means either A belongs to P or B belongs to P. Therefore, singleton 0 is a prime ideal in Z. Next, generator x comma y is a prime ideal in Zx comma y. Sixth, A belongs to closed interval 0 comma 1 is a prime ideal in C01. C01 is the set of all continuous functions whose domain is closed interval 0 comma 1 and codomain is real numbers. Next theorem. This theorem is very important. Let R be a commutative ring with unity and I be an ideal in R. R by I. This is an integral domain if and only if I is a prime ideal in R. R is a commutative ring with unity, I is an ideal in R. Then this quotient ring or this factor ring R by I, this is an integral domain if and only if I is a prime ideal in R. In short, R by I is integral domain if and only if I is prime. ऐसे शॉर्ट में याद रख सकते हैं, ठीक है. Now next is maximal ideals. Let R be a ring a proper ideal M is called a maximal ideal in R if whenever J is an ideal in R such that M is contained in J, J is contained in R, then either M is equals to J or J is equals to R. R is a ring, M is a proper ideal, M is called a maximal ideal in R if whenever J is another ideal in R such that this M is contained in J, this is contained in R, then either M is equals to J or J is equals to R. Then we will say that M is an maximal ideal. Next theorem, this is also important. Let R be a commutative ring with unity and M be an ideal in R R by M. This is a field if and only if M is a maximal ideal in R. That is, R by M is field if and only if M is maximal ideal. This theorem and this theorem, both these theorems are useful in MCQs. Now let us discuss some examples of maximal ideal.
एक मिनट मैम थोड़ा स्क्रॉल करना ऊपर मेरा नेट चला गया था.
कहाँ से?
हाँ बस यहाँ मैक्सिमम आईडी से.
दोबारा बताऊं?
हाँ एक बार बता दो.
So maximal ideal. R is a ring. M is a proper ideal. It is called maximal if whenever J is another ideal in R such that M is contained in J and J is contained in R, then either J is equals to M is equals to J or J is equals to R. Then we will say that M is a maximal ideal. Next, this theorem is very important. I was telling that this theorem and this previous theorem both are useful in case of MCQs. Here also R is a commutative ring with unity and M is an ideal in R. Then R by M is a field if and only if M is a maximal ideal. So R by I is an integral domain if and only if I is prime. R by M is a field if and only if M is maximal. Means if field is given, then ideal will be maximal. If quotient ring will be integral domain, then ideal will be prime. This is if and only if result. Now let us discuss some examples of maximal ideal. First example.
एक मिनट ये ऊपर वाली थ्योरम लिखूं जैसे एग्जांपल के ऊपर वाली बस. हाँ कॉन्टिन्यूअस.
NZ is a maximal ideal in Z if and only if N is prime. For example, here ring R is set of integers and we know that ideals of Z are of NZ type. So if I take I as 2Z, I need J लेते हैं, J को 2Z. J as 2Z, then it was like this. M is contained in J and J is contained in R. So 2Z. हमें तो चेक करना है ना, तो इसी को लेना था. M2Z. M is 2Z. This is contained in some proper ideal J and it is contained in set of integers. So this will also contain ideal of Z. So if it contain ideal of Z, then this J will contain all even elements plus all odd elements. And in ideal, we know this definition that A minus B again belongs to ideal, na? Ideal test. So in ideal, 2k plus 1 minus 2k means odd elements minus even elements. So this will be 1. And we know that if 1 belongs to ideal, then what will happen? If unity belongs to ideal, then ideal is equals to ring, na? I is equals to R. We have discussed this before also, this result. So this means that J is equals to Z. Which is a contradiction. Therefore, 2Z is not a maximal ideal of Z. Next, if I consider this example, ring is set of integers, ideal is 4Z. Now clearly 4Z is not a maximal ideal of Z. यहाँ पे मैंने रॉन्ग कर दिया, ये प्राइम है 2 तो ये आइडियल बनेगा, 2Z बनेगा मैक्सिमल आइडियल. यहाँ पे ये 4Z है, 4 is not prime, so it will not be maximal ideal because 4Z will be contained in 2Z and 2Z is contained in Z. So similarly 3Z will be a maximal ideal because 3 is prime. So in general, NZ is maximal ideal in Z if and only if N is prime. Second, the maximal ideals in Zn are given by prime divisors of N. Zn is isomorphic to Z by Nz. So the maximal ideals of Z by Nz are Pz by Nz, this type, where P is a prime divisor of N. Third example, generator x square minus 2 is a maximal ideal.
Number of prime divisor of N.
Yes, P is a prime divisor of N.
The number or prime divisor, जैसे अगर फॉर एग्जाम्पल 9 है तो 9 के नंबर ऑफ प्राइम डिवाइजर्स है या फिर ओनली नेम, जैसे 3 है 3 प्राइम डिवाइजर हो गया,
only 3. जैसे Z6 हुआ तो 6 की तो प्राइम फैक्टराइजेशन 2 into 3, तो 2 और 3 दोनों लोगे आप फिर. तो मैक्सिमल आइडियल्स ऑफ Z by 6Z, they will be 2Z by NZ. 6Z means Z by 3Z and 3Z by 6Z means Z by 2Z. So these two will be maximal ideals. Now next is generator x square minus 2 is a maximal ideal in Qx. So define f mapping from Qx to Q root 2 as, now why I have taken Q root 2, because if I put x square minus 2 equal to 0, then I am getting x is equals to plus minus root 2 and ring is Qx. So that's why I have taken this Q root 2. So this will be defined as, this will be a polynomial ring, a polynomial whose coefficients belongs to rational numbers. So f gx is equals to g root 2 for all gx belongs to qx. Then f is an onto homomorphism and also kernel of f. This will be gx belongs to qx such that gx is equals to 0. This means that gx is equals to f gx is equals to 0 such that g root 2 is equals to 0, gx belongs to qx. So this is generator x square minus 2. Now by first isomorphism theorem, qx by generator x square minus 2 is isomorphic to q root 2 and q root 2 is a field. Now if q root 2 is a field and this is isomorphic to this quotient ring, then this will be also a field. So this implies qx by x square minus 2 is a field. Now I can apply that theorem that if R by M is a field, then M is maximal ideal. So x square minus 2 is a maximal ideal in Qx. Because R by M is a field if and only if M is a maximal ideal in R. Next example, fourth, generator X is a maximal ideal in Qx. So we will define like this, define psi mapping from Qx to Q as psi fx is equals to f0 because roots of this ideal is 0 only for all fx belongs to Qx. So psi is an onto homomorphism. Now what is kernel psi? This will be fx belongs to Qx such that psi fx is equals to 0 and psi fx is f0. So fx belongs to Qx such that f0 equal to 0. So this will be generator X. Again by first isomorphism theorem, qx by ideal x is isomorphic to q as rational numbers is a field. So qx by generator x is also a field, and by that theorem generator x is a maximal ideal in rationals. Okay. Next example, ideal x comma 2 is not a maximal ideal in qx. Sixth, x square plus 1 is a maximal ideal in Rx. How? Try this once, that how this ideal x square plus 1 is maximal in Rx.
इसको उससे करेंगे कॉम्प्लेक्स नंबर से x इक्वल टू रूट
Yes,
a प्लस आई भी कर
codomain will be complex numbers.
पर सॉल्व कैसे करेंगे इसको सेम लाइंस पे
Same.
इसमें जो हम कर्नल डिफाइन करेंगे फिर उसको 0+0 आइटा ले लेंगे
कर्नल 0+0 आएगा.
क्लियर नहीं हो रहा, इसको कैसे करेंगे? लाइक एक्स स्क्वायर प्लस 1 मैक्सिमम आइडियल हो गया, तो हम इसको लिख सकते हैं एक्स स्क्वायर प्लस 1 इक्वल टू 0, एक्स इक्वल टू रूट आयोटा, नहीं सॉरी एक्स स्क्वायर इक्वल टू आयोटा, है ना? और प्लस माइनस आयोटा कह लो, तो प्लस माइनस आयोटा, तो इसको हम वैसे डिफाइन करेंगे जी एफ ऑफ जी एक्स जी ऑफ आयोटा करके।
पहले आप ये बताओ आपने मैपिंग क्या डिफाइन करी? आर एक्स टू कॉम्प्लेक्स नंबर्स।
अच्छा आर एक्स है, हाँ सॉरी आर एक्स कॉम्प्लेक्स नंबर्स करी, हाँ राइट।
psi fx is equals to f iota for all fx belongs to rx. Then psi is an onto homomorphism. Kernel psi, this is equal to fx belongs to rx such that psi fx is equals to 0 and psi fx is f iota. So in this kernel, this will be ideal x square plus 1 because if I put iota in this will be 0 ना. रूट्स तो इसके दो ही आते हैं, एक्स स्क्वायर प्लस 1 इक्वल टू 0, पर हम कोई भी एक लेके कर सकते हैं क्योंकि एक्स स्क्वायर है ना. सेम ही बात है, अगर एफ माइनस आयोटा लेती तो भी तो मेरे पास सेम ही आता. देन बाय फर्स्ट आइसोमॉर्फिज्म थ्योरम, आगे क्लियर है कैसे होगा? फर्स्ट आइसोमॉर्फिज्म थ्योरम ध्यान में है.
आर एक्स बाय एक्स स्क्वायर प्लस 1 जनरेट करना.
This is isomorphic to complex numbers. Complex numbers is a field. So Rx by generator x square plus 1. This is also a field. And by that result, R by M is a field if and only if M is a maximal ideal. So x square plus 1 is a maximal ideal in Rx. Next example. Let A belongs to closed interval 0, 1 be arbitrary. IA, this is equal to fx such that fa is equals to 0 is a maximal ideal in C01. Now define psi mapping from C01 to R as psi fx, because this C01 contains continuous functions, so I am taking this as fx. This is equal to fa for all fx belongs to C0, 1. Then psi is an onto homomorphism. Kernel psi, this is equal to fx belongs to C01 such that psi fx is equals to 0. Psi fx, this is fa equal to 0. So this will be our IA. Now by first isomorphism theorem, C01 upon kernel, kernel is IA, this is isomorphic to set of real numbers, and set of real numbers is a field, implies C01 upon this is a field. R by M is a field if and only if M is maximal. So this IA is a maximal ideal in C01. Note, every maximal ideal in C01 is of the form IA, where this A belongs to closed interval 0, 1. There exists a prime ideal in C01 which is not maximal. Next, 8th example. This is very important. Ideal x comma y is not a maximal ideal in zx comma y, because if I define psi is a mapping from zxy to z as psi fxy is equals to,
तो डायरेक्टली कर सकते हैं जेड इज नॉट अ फील्ड.
z is not a हाँ उसी से ही करा है, बस वो तो मैं थोड़ा डिफाइन करके बता दी थी कि कैसे है. Psi is an onto ring homomorphism. Kernel psi, this is equal to ideal x comma y by first isomorphism theorem. Zxy upon ideal x comma y is isomorphic to z, as z is not a field. Why z is not a field? What was the reason?
That is not a field because it is not integral domain, no?
Z is an integral domain.
That is integral, but it's not a field.
फील्ड नहीं होने का
हिसाब से यहाँ पे वो नहीं आएगा ना, इनवर्स एग्जिस्ट नहीं करेगा ना विद रिस्पेक्ट टू मल्टीप्लिकेशन.
Yes, simple reason, multiplicative inverse of every element does not exist. This is isomorphic, so this is also not a field. So R by M is a field if and only if M is maximal. Now if R by M is not a field, then M is not maximal. So ideal x comma y is not a maximal ideal in zx comma y. Now next is some properties of maximal ideals. First, in a commutative ring with unity, every maximal ideal is prime. Means maximal implies prime. The converse need not be true. Every prime ideal need not be maximal. For example, generator X is a prime ideal in ZX but not maximal. Next, second, in a finite, so in a commutative ring with unity, every maximal ideal is prime. If I want that converse should be true, then the ring should be finite. In a finite commutative ring with unity, every prime ideal is maximal. Third, in the ring of integers, every non-zero prime ideal is maximal. Fourth, the only ideals of a field are singleton zero and field itself. Note, if R is a commutative ring with unity such that the only ideals in R are 0 and field F, then R is a field. Fifth, let R be a commutative ring with unity, M be an ideal in R such that every element of R not in M is a unit, then M is a maximal ideal in R. R is a commutative ring with unity, M is an ideal in R such that every element of R which is not in M is a unit, then M is a maximal ideal in R. Now let us practice some questions. First question, pick out the true statements. A part, the set of all 2 cross 2 matrices with rational entries with the usual operations of matrix addition and matrix multiplication is a ring which has no non-trivial ideals. B part, let R is equals to C01 be a ring with the usual operations of pointwise addition and pointwise multiplication. Let I is equals to f mapping from 0, 1 to real numbers such that f1 by 2 is equals to 0. Then I is a maximal ideal. This question is MSQ. C part, let R be a commutative ring and let P be a prime ideal of R. Then R by P is an integral domain.
in P.
Why not C?
C competitive rings.
ये भी तो होगा ना.
प्राइम आइडियल तो है, तो R by P फील्ड होगा.
नहीं, R by P is an integral domain if and only P is prime. ऐसे होता है ना.
अच्छा अच्छा, किस करके प्रॉपर्टी
फील्ड तब होता है R by I is a
वो
field.
मैक्सिमल हो,
हाँ, वो
मैक्सिमल हो ना.
मैक्सिमल.
हाँ
ठीक है. So C is also correct. B is also correct. It is same as F A equal to 0. Only A is equals to 1 by 2 is there. सेम ही है जो भी ये वाला मैंने करवाया था, आई ए वाला एग्जाम्पल, ये वाला सेम है. इंस्टेड ऑफ ए इट इज 1 by 2, so it is maximal. And A part, set of all 2 cross 2 matrices form a ring which has no non-trivial ideals, and also the entries of this matrix was from rational. So if I pick two matrices from this M to Q, this implies A plus B belongs to M to Q because Q with respect to plus forms a group. Minus B also belongs to M to Q because Q with respect to addition is a group. So as Q is a field, we know that if F is a field, then the only ideals of F are identity and itself. So as this is a field and has only trivial ideals, identity and rationals, this means that M2Q has no proper ideals, because if M2Q has proper ideals, then Q will also have proper ideals, which is a contradiction because Q has only trivial ideals, identity and rationals. So this forms a ring. So answer is options A, B, C. Second question. Again, MSQ. Pick out the true statements. A part, let R be a commutative ring with unity. Let M be an ideal such that every element of R not in M is a unit, then R by M is a field. B part, let R be as above and M be an ideal such that R by M is an integral domain. Then M is a prime ideal. C part, let R is equals to C01 be a ring of real valued continuous functions on closed interval 0, 1 with respect to pointwise addition and pointwise multiplication let M is equals to F belongs to R such that F0 is equals to F1 is equals to 0. Then M is a maximal ideal.
इसमें ऑल करेक्ट होंगे तीनों?
नहीं,
सी ऑप्शन में डाउट है, फिर मैंने ए और बी तो करेक्ट है.
so A part is R is a CRU, M is an ideal such that every element of R not in M is a unit.
हाँ, तो मैक्सिमल हो गया ना.
तो मैक्सिमल हो गया, तो R by M फील्ड हो गया.
हो गई. हाँ, सेकंड में एवरी मैक्सिमल इज प्राइम. सेकंड में 2 हो गया.
यस.
थर्ड में डाउट. थर्ड में कर्नल
बी पार्ट में आपने ये क्यों बोला कि मैक्सिमल हो गया तो प्राइम हो गया?
था ना कि प्रॉपर्टी थी ना मैक्सिमल की इन अ CRU. ये CRU है ना, कम्यूटेटिव रिंग विद यूनिटी एवरी मैक्सिमल आइडियल इज प्राइम.
बट वो अप्लाई करने की नीड ही नहीं है, या तो डायरेक्ट है R/M इज एन इंटीग्रल डोमेन इफ एंड ओनली इफ M इज प्राइम.
हाँ वो भी कर
नोटेशन चेंज
सकते
कर
हैं.
दी बस उन्होंने.
हाँ.
B is also correct. So in this C हमने बस अब तक F0 इक्वल टू 0 या फिर F1 इक्वल टू 0 इस तरह से पढ़ा है. दो रूट्स इकट्ठे आ जाए ऐसा कुछ नहीं पढ़ा अब तक. ठीक है. So let M is equals to F belongs to R such that F0 is equals to F1 is equals to 0. Consider M dash as F belongs to R such that F0 equal to 0. Now M is contained in M dash, and we know that M dash is a maximal ideal. Now when M dash is a maximal ideal, so M cannot be maximal. जब M dash ही maximal हो गया तो M कहाँ से maximal हो जाएगा? And hence M is not a maximal ideal. Means अगर दो रूट्स गिवन होंगे ना तो वो maximal नहीं आने वाले आपके. So C is wrong. Answer is option A and B. The only idempotents in the ring Z51, that is Z by 51Z, are 0 and 1. True or false? Paper 2019. Now Z51 has how many elements? 51 elements. I cannot check for which elements idempotent is there. So there is a formula for this. In any ring Zn, number of idempotents is equals to 2 to the power k, where k denotes number of distinct prime divisors of n. Now here n is 51. 51 is 3 into 70. So there are two prime divisors of 51. That is k is 2. So number of idempotents in Z51 is equals to 2 to the power 2, 4. So answer is false. Let ring be Z cross Z cross Z and I is equals to Z cross 0. Then which of the following statements is correct? A part, I is maximal but not prime. B part, I is prime but not maximal. C part, I is both maximal as well as prime. D part, I is neither. A maximal ideal nor a prime ideal.
तो सी पार्ट आएगा।
नहीं, so
से हम यूनिट लेंगे अगर आर में तो ट्रिपलेट हो गया ना जेड को सो आर 1 1 1 हो गया ना यूनिट तो
simple by definition जाओ. This will be contained in z cross 2z, and this will be contained in z cross z. So clearly we can see that this I is not equal to this, neither this is equal to this ring R. So it is not a maximal ideal. So A part and C part, they are wrong. Now to check prime ideal. प्राइम आइडियल के लिए तो सिंपल लॉजिक देख सकते हैं. एक ही मैंने बताया था कि सिंगलटन जीरो इज अ प्राइम आइडियल. बताया था ना मैंने. बेसिकली दिस इज अ प्राइम आइडियल in Z but not a maximal ideal. ठीक है. So answer will be option B.